Guys, this is homework help for GPE, KE, EPE, and the work energy theorem practice problems. There are several equations that would be helpful to consider as you're working through these. So let's go through those real quick. First, we've got the basic work equals force times distance. We've got gravitational potential energy equals mass times acceleration due to gravity times height. We have elastic potential energy equals 1/2 times the spring constant times the stretch or compression distance squared. And then we have kinetic energy equals 1/2 times the mass times velocity squared. And then we always want to remember in each of these cases that work can cause a change in GPE. So we can set those equations equal to each other. Work has to be done in order to stretch or compress something, so we can also say it's equal to a change in EPE. And finally, work will have to be done to speed up or slow something down, so it is also equal to a change in kinetic energy. Okay, so with those equations under our belt, let's look at the first one. We have a 6.4 kilogram bowling ball being lifted 2.1 meters into a storage rack. And question A asks how much work was required. So first of all, was work done? Well, we've got a bowling ball that's being pushed up, and it is also traveling a vertical distance, so yes, work is being done. Our formula for work is force times distance. So when you lift something, the force is going to equal the weight of the object, right? So we're going to need to find the weight of that bowling ball. To do that, we're going to use our old friend, the equation Fg equals mg. So we have a 6.4 kilogram bowling ball times 9.8 meters per second squared. And that gives us a force of 62.72 newtons. Okay, so that gives us the force. And then we have a distance or a height. And so when we're doing our work formula, we're going to say 62.72 newtons times the distance of 2.1 meters. And we get our answer of positive 131.7 joules. That answer, of course, is positive because the force and distance are not only parallel but in the same direction. Question B says, what was the increase in the ball's gravitational potential energy? So our bowling ball had to be lifted. We did work, and in doing so, now it has a height. And so we can say that the work done equals the change in gravitational potential energy. Therefore, the work we found up above equals the GPE that the ball has at the new height. Okay, if we move down just a little bit, look at number 3. That's our problem that deals with EPE. So let's take a look at that one. So we've got a 0.25 kilogram pop-up spring toy. That's a mass, of course. It's compressed 0.03 meters, so we call that X. And then released. The students observe the popper springs straight up before balling back to the table, excuse me. So this is one of those toys that like sits on the table, it flies up, and then it drops straight back down. It tells us in letter A that the spring has a spring constant of 1041 Newton per meters. We call that K. And we want to know how much elastic potential energy did the toy have before it popped up. So our formula for elastic potential energy is EPE equals 1/2 times the spring constant times the compression distance squared. So we can say 1/2 times 1041 for K times 0.03 meters for X, and we want to square that. And so when we put all that into our calculator, we get a total of 0.47 joules for EPE. That was down here, by the way, while the toy is sitting on the table. Letter B says this is happening in physics land. There's no air resistance. And we want to know how much gravitational potential energy will the popper have at the top of its trajectory. Well, we happen to know that energy can transform, that work had to be done. The elasticity of the toy and the spring causes work to be done as it travels upwards. And so we can say that the EPE at the bottom will equal the Gpe at the top. And so that's where we're getting the 0.47 joules answer again. And then the last part asks what height will the popper reach. So we want to choose the Gpe formula because it deals with height. It's m times g times h. So the mass was given at the beginning, 0.25 kilograms. G, this popper's on the Earth, so that's 9.8. And then we're looking for the height. And the actual Gpe amount we said was 0.47 joules. Okay, so first step is to multiply 0.25 times 9.8, and that gives us 2.45 times an unknown height equal to 0.47 joules. Next step will be to divide both sides by 2.45. And so that gives us our final height of 0.19 meters. And that is our final answer on that one. Yeah, I hope that helps. Reach out if you've got questions.